the topic assigned to me is database and research metrics. And few years from now, I'll be talking on this database and research metrics. Initially, all I learned that you all are the research scholars who have joined in this particular course. So, not really. My question, first question is, in context with the database and research metrics, but in a general, like why you want to pursue research. So, and if you comments, I will receive. I will like to receive from you. So, the statement of purpose for your pursuing your PhD, if anyone can tell me, I would like to hear from you. Yeah, participants, please. Why you want to do research? What is your purpose? And as we are online, I can't monitor all of you, but I want your inner voice, rather than Google search or research. I'd like to hear from you why you want to do research. I'm audible, right?
Yes, sir.
Yeah.
There are certain answers to upgrade our knowledge in the chat box, to learn new things.
Yeah, before this question, actually, I would have asked like the better other things to know you better in better way. Um, Anyone other than teaching in this on this platform?
Yes, sir. There are certain scholars from
Yeah, are they present? Are they
industries.
present? Are they
Uh,
present?
Let me check,
Yeah,
sir.
just they can raise hand.
Yes, sir. They are present. Abhay sir is from industry.
Okay,
I know about them. Him only. He's
okay.
from industry.
Uh, there is Mr. Meza. He has raised hand. He is from industry, and now 29 people are on board. One raised hand. So I think all other are yeah. Karuna Shinde. She also raised hand. So in the crowd of 31, two people from the industry. Okay, only one, Mirza. Only Mr. Mirza is from the industry. Rest all are from the teaching domain. Okay, that's fine. Um, why we want why to do research? Okay, I can see some replies in the chat box. To upgrade our knowledge, to learn new things, to get knowledge in my domain, to get proficiency in any one domain. Okay, so as most of you are teacher, so I want to know the from teacher, why we want to do research from that perspective. Okay, the knowledge upgradation is throughout the life. Whether you do PhD or you don't do PhD, we learn many things. So, why particularly this PhD is required? Particularly when we look as into the academic fraternity, be teacher. Why we want to do PhD? Why we should do PhD? Again, my opinion will be my personal opinion. Yeah, career advancement. Yeah, career advancement. So many, eligibility criteria are set for promotion. So the PhD is mandatory. To understand what innovation is going on in a particular domain and keep ourselves updated. Okay, any more? 1 or 2 minutes I can spare for more replies. I want your inner things. I mean, maybe there's also like something catching career advancement. Yeah, people may get motivated because of rules regulation and they want to do PhD. That maybe it might be the agenda. Okay, so good. So many of you have mentioned about to upgrade knowledge or to know the new things or to understand innovation, discover something new, proficiency increment, improvement, and including career advancement as well. Okay, so the my version, if you ask me again, as I mentioned to you, it is my personal opinion, but I passionately came into this profession, into the teaching. So why I want to do research. This is my version. If I want to do research is to enhance teaching, and when there is a discussion on research in our academics with our colleagues. Normally, many of our colleagues talk about our institute is not research institute. We should not do research. We are into the academics. We should focus on academics. Research is not really the for which our institute is meant for. This is the common, most people throw the comments like when we have the casual meetings uh, or gatherings of our faculty. But still, I endorse that we want to do the research very strongly. I endorse it. The reason is, when we are the teacher, right? We are the first aim or the first target or the duty is to teach. But how the research is important? Why we should do research? The thing is, when we enter a class of a 60, normally the intake is 60 of undergraduate, you will definitely find the students who are very fast learner, and they will ask you some questions which are really challenging for you. No matter how many years you are teaching the course, but every year you'll find one or two guys asking you the questions which may give you some kind of to scratch your head. Really, the quality question, but the questions asked by the students, there may be one or two in the class of 60. Okay, I think you'll agree with this. And again, you'll find in the same class a few students, maybe again quite a single digit number, who don't understand at all your course, even the fundamental. You will be surprised knowing them how they are in that particular year or for that particular course, because the fundamentals are so big and they can't understand what you're telling. Okay, so these are the two extremities that definitely you would have come across whenever you're teaching the course at any time, no matter how many years you are teaching that course. But always you'll find these two extremities. Some fast learners, they want to do something else. The questions are really very challenging, and they want to do something very very out of box. Maybe the number of students are less asking this question, but yes, and few students who don't understand at all. Otherwise, I will say they don't have any interest, but by some forces they come into the engineering or in your discipline, and they are listening to you because of the mechanism that we want some attendance or something. Okay, so these two extremities you always will find. So how the research will help, so why we want to do research? The research is to help these two extremities basically. Okay, you can't, I mean, as a teacher, it's not good to answer the fast learner, okay, that it's out of syllabus or don't think on this. It's not the good answer to the student who's really out coming with out of box thinking. If you are doing research, really you will help him out in pursuing that out of box ideas, or otherwise maybe you'll formulating the feasibility and viability of the idea which the student has presented. So the research will give you the firm standing, and really the good discussion with such student fast learner. We often academics goes across different accreditation, maybe NBA, NAC, some maybe going for this abet accreditation and so on. They always people asking you how you are serving the fast learner. And in national education policy also there's a lot of the things mentioned about the fast learner. You offer honor degree and so on. So if this is the case, that is for fast learner, research is going to help you out. Okay. So the basic is, I mean, if you are doing a research, really you are good in position to handle such things, such questions. And these questions are, you never know what kind of a questions the student or the fast learner is going to ask you. So, but the research attitude really will help you. If you're doing a research in that domain, then you will be able to address those particular question, or otherwise may be able to do the feasibility study or viability study on the ideas presented by the fast learner. Other extremities is, I talked about the students who is there in a class but don't understand fundamentals of your course, because the previous prerequisites are not properly taught, or may not be like properly addressed. And you just land up in your class, and you are, I mean, he is struggling to get into the basic fundamentals, and that may lead to the failure of the student. So for them also, the research, if you're doing research, then for, you will be in good position to address them also, because then you'll come up with a different pedagogy. You may take him to your research laboratory or your setup developed in your research, and will make him to understand what you want to convey in 4 words. So you will take him out. You will take him out and then lead it to the laboratory, demonstrate something, or you may animate using computer simulation tools, or something that you will do, some pedagogy development. Okay, the research will give you that idea. Okay, that tool to really educate such a person or such a student who is very very weak or very difficult to understand, with the average people he cannot cope up, or maybe out of interest he is there, but you may ignite him and bring the interest into it. So this is why, research is important. This is why the academician should do the research. Okay. So as a teacher, why we do want to do research is this. This is my version. Okay, this is my version. Why the person, or why the academician should do the research. Okay. Any other thoughts? I talked about on research, my perspective. Anyone want to convey something? Better you talk, rather than putting message in chat, because when I'm sharing my screen, I can't see the chat. That's the problem. Is any thoughts, any discussion on my version, or you are coming with your version or your idea? Okay, so let me go to the assignment given to me, rather than more on interacting. You can discuss with me if you someone is want to discuss really in the in-person mode. I'll share my email and mobile number later at the end. So I'll stick to my job for this evening. So I'll be talking on the database and research metrics. Okay. So database and research metrics is basically is evaluation of your research. I talked about research, why we want to do research. So next slide is about research cycle, and then soon I'll come onto the database and research metrics. So what you will be doing very first is the review the literature. You will be reviewing the literature available in your domain, various articles, particularly the journal we recommend. You would have been guided by your supervisor or guide, like to see the research articles from the peer-reviewed journal, okay, peer-reviewed journal or the publishers, and then you'll be reading all those, and that is what actually we do the literature survey. So you should know the state of the art. What is the present status of the research? Maybe a national wise or nationwide or international wise. Okay, what is the available status? And then from that you will be formulating a question for your own research. So you will be finding the gap. Again, finding the gap is crucial. It takes sometimes a long time, but this is a process of or cycle of the research, and you have to come up with the question formulation, and that should be the viable and feasible. You can't say like I'll be solving and proving that 1 plus 2 is equal to 4. No, gap, but whether that gap, the proposal you want, you are going to come with, is it's viable, feasible or not. Sometimes you go back, your gaze goes wrong, and you go back and again you formulate the question. That may happen. Iteration may take place, and then you, if you are very fine with that, you find yes, this is the possible possible direction. Then you select the appropriate research design. You design to analyze, you analyze and design, what for that particular problem which is you are going to solve. And then you collect the relevant data from the experimental setup or observation or simulation, whatever it is. Might be you made and design something, experimental setup, and then that's a design, basically setup design or something, and then you will run the experiment, and you collect all the data from the experiment. You will fit it into the model, mathematical model, maybe experimental, and then you may dig into the physics of the problem, and you will find out the physical model of the same, physics driven model, I mean, or maybe a computer simulations. Okay, something like that depends upon your what type of the problem or the domain you are working. And then important is the interpreting the result. It's many times happens, the you uh, do the experiment. Okay, you get the data. Okay, you collect all the data, plenty of the data. You have good tools nowadays, hardware, software tools to collect the data. And then but the problem with nowadays, when I'm interacting with my student also, the interpreting the finding is a big issue. Okay, so you should know like what is the data you obtain and what is it. It's like behind the data. Okay, that's important. I may take one quiz for this. Okay, in between, if we can discuss it for a while, and then I'll go to the database. So let's see, this is a quiz where there is a one tank and there is a water up to certain height, and then the water is coming out from the hole which is in the tank, and the jet is coming out from that. And you can see like there is a jet which is a paraboloid and tracing up a parabolic path here. Okay, now the it is proposed to lengthen this jet without changing the height edge. What you will do? Can you tell me, anybody? If you have to lengthen this jet, what you'll do? Is anyone? Is the question so difficult?
Radius will decrease.
Yeah.
Radius should be decreased.
Yeah. Diameter will decrease. Absolutely correct. Okay, you will decrease the diameter. And now the next question. Participants shall propose the possible way. Yeah, so diameter is decreased. Can we draw a generalized conclusion? Yeah, I agree that the diameter is decreased. Your jet length is increased. Can we draw a generalized conclusion that decreasing diameter of throttle opening will always increase lengthening of the jet? Yes or no? Can we draw this generalized conclusion that if the diameter is decreased, the jet will always, lengthening of the jet always will happen?
We can't say like that, sir. I
Okay,
mean,
why? Can you elaborate your justification to your statement.
I mean, increasing the diameter don't have anything to do with length of the jet. Maybe because I'm not from this mechanical. I mean this background. I'm CA student.
Yeah, that's okay, but this don't require any. I mean, such a rigorous mechanical engineering. It's general observed phenomena, right?
Increasing.
So this is based on observation, right? So if the diameter is decreased, always jet increase. But often seen, right? When the diameter is decreased, jet increases, right? Have you seen sometimes when diameter is further decreased but jet is not increased? How many? I mean, I can any? I mean, anyone says yes, yes. This is generalized statement. Anyone in this support of this statement?
Venkat sir can't hear properly. Are you talking something?
Okay,
Sir, there is one answer. Yes, Pallavi ma'am is saying.
okay,
Yeah,
fine. Uh-huh. Okay. Let's go in. So see what you would have seen a tank with a nano punctured hole, and you can't see the jet. I mean, lengthened jet, but rather a droplet coming from it. Right? Agree or not? Agreed or not? Have you seen such thing?
Yes, sir. Yes, yes.
Yes, sir.
Okay. Yeah, I mean, this you would have observed, no? This a small punctured hole and droplets coming. You can't see like jet, okay, of long length. But again, the previous phenomena which I mentioned, big hole and then you are reducing the diameter, jet increasing. But you go on decreasing the diameter, you will not see like jet is increasing. Okay, you will see then at the end, what is happening is a small droplet is coming. And now I'm not going to dig more into the mechanical engineering. Next question is more into the mechanical. This is just observation. Here we don't read really a mechanical engineering fundamentals or a knowledge. Okay, but this is so. What I want to convey to you is we really don't. Really want to see or interpret the finding. Okay, this pink color is not the generalized statement, generalized conclusion. This is what the problem with sometimes happening with the research scholars. No, they get the data and the conclusions they are not really presenting with a deeper thought. Okay, so you need to have a deeper thought. Decrease in diameter, increasing length is subject to some condition, not valid as a generalized conclusion. You see, like this this case, further decrease in diameter, you are getting a drops coming out. Okay, a different physics is playing when the diameter of the hole is in tune of some micron or nanometer. Okay, so this is where is important and an important step in the research cycle. Interpret your finding and present the proper conclusion and the discussion and then conclusion. And then publish the finding. You publish it properly. So these findings need to be presented well. Okay. Then only your article will get accepted in very good journal. So my talk is about database and research metrics. Okay. So research metrics is about what? Is about your article, about your work, or about journal. Okay, about your institute department. Okay, so when it happens when you publish, and when you're publishing it good journal, it automatically this indices or this metrics figures will be good. Okay, this is the last step, publishing the findings. You do everything and then you publish, and then it becomes a literature for the next researcher, and then cycle goes on. Okay, now I'm coming to my topic main, which is assigned to me. So the database and the research metrics. Okay, so the topics were actually the content of the topics of this my talk, which I am going to cover in my talk is why access this scholarly impact research. Why? So overview of this metrics and tool. There will be different metrics. One is for journal, the journal which you where you are publishing. What is the metrics of that journal? The article means you submitted paper in the journal and then it gets published. So what is the metrics of that particular article, your publication published article? Okay, maybe a conference article or book, or maybe a journal article. So what is the metrics of that? And then author metrics. You publish in your career so many articles, journal paper, conference paper, and so on. And then the metrics comes for you. Okay, so that is the author's metrics. So research metrics means it deals with journal metrics, article metrics, author metrics. Okay, now you would be knowing. I mean, as most of you are from faculty. Most of you are faculty from the academics. Only one, Mr. Mirza, is from the industry. So, Mr. Mirza, if you are not, I mean, acquainted with some of the term, and I presume that it is known because of some. I'm also like from faculty academic background. You can interrupt me. Okay, so these are the metrics. Many of you might be knowing this because you are into the academics and you would have undergone the some accreditation and all. And there are so many, these metrics are asked like H index, I index, and you also would be having your own score known to you from Google Scholar and Google Scholar, etc. So here, I'll be giving you the overview of these metrics, how they are calculated, and what are the importance. Very commonly in Google Scholar, if you see now H index, I10, and so on. But there are some pros and cons with all this, and because of that, now new things has come, and that is called Altmetrics. Altmetrics has a different, the constituents for assessing your quality of your research done. So we'll discuss that Altmetrics as well, and the current issues in this direction of database and research metrics and the future consideration. So this is the flow in which I'll be going here. Okay. Now, when we talk about how the impact is done by our research, so when we talk about like how many people have read our article. It is one thing. Extent to which the research is done. So how we gauge that? How much is our impact of our research? So we analyze it by read, how many reads that article has made. So normally now the journal, wherever you are submitting in a good standard journal, when you are referring to the site of the journal, any publisher you take a very standard publisher like Springer or Elsewhere, Taylor and Francis, ASME, Mechanical Engineering, IEEE, Transaction, and so on. You will come across for every article they give you how many reads that article has been so far. How many people have read it? How many people have downloaded it? How many people have cited it? Again, in citation, there are different platforms. You have Scopus, then you have the Crossref. So how many Crossref citation or the Scopus citation, citation it is received? That all metrics you will get for your article or for the journal. So, but the impact is, is given by read, how many discussed it, used it, and then how many disseminated it, right? How many have talked about that particular article. Sometimes, the teacher may ask the question also based on some articles. So that is the dissemination, or may discuss in the seminar about some work done and cite it. So that is also the dissemination. So this is what actually is about the impact when we call about the impact of the research into the community. And why we measure all this? Why we do all this? Why we find out these figures? How many downloaded? How many read? How many cited your article, etc., etc. So it's all about knowing the research quality. How much is impact means what? Like how much is the quality research you have done? Okay. So why we measure it? We measure it for research quality. We find out the potential for grant funding when you are applying for the project grant to some bodies, in India, like Department of Science and Technology, SERP, or Department of Biotechnology, so on. There is always a question for the reviewer, how much is the confidence of the principal investigator. How that question is answered? That question is answered based on this metrics. How many publication he has done? What is the metrics of that publication? Where he has published? What is the impact factor of that journal? How many citations received in last 3 years or 5 years? So that decides the confidence of the PI. So we measure it to know the potential, assess the potential for grant funding. Then job market. Nowadays, there are plenty of for the researcher available, and how they evaluate researcher is based on this particular metrics. Prove the productivity. How much is your research is impactful from the technology transfer point of view, or from the developing some product point of view. So that also is decided by this metrics. And of course, for the faculty, it is one of the important parameter for promotion and tenure. Not in university affiliated colleges like us, but maybe if you are targeting into some central institutes, then they see all these particular parameters very keenly. When you are applying as the direct entry there or for the promotion also, they see this very carefully. And what else you might be knowing? These are some of the points which I get. Okay, so there are plenty of the reasons for which the metrics is important. So, what are we measuring with it? With it is the journal quality, article reach, how much your published article is rich, to which area, to which domain, to which people, its impact, its influence, okay, done on the community in the engineering society, etc., etc. Dissemination, okay, researchers' impact. So these are few of the things which are the we are measuring through this database and research metrics. Okay, so journal level metrics measures quality of journal using citation formulas. So there are, as I mentioned in my talk, so far I have not come to that level to address to all these calculations, but still ahead of that I told so many terminologies such as I index, the H index, I10 index, and so on. Okay, okay. So these are these are based on certain formulas or calculations. So there is a methodology. As further again mentioned, for each of this methodology there is pros and cons, right? So, but yes, a few of this index are taken as a standard and used for measuring the quality. So these journals are measured by this citation formulas. Articles also are measured for this particular indices based on the citation base. Or nowadays, I mentioned recent trend has come, which gives emphasis on altmetrics. Okay, citation based, otherwise altmetrics based uh, analysis of your article. Then author level, your personal impact onto the engineering society or in any society, research society, I mean to say, also can be measured by the bibliographic impact of individual authors. And then alt metrics is a new term they come into the citation and research metrics, which measures and monitors reach and impact of research through online interaction. The altimetric also takes account, how many the people comment, how the people comment on Twitter or some social media, etc., etc. That also is considered. How many people from the other domain uh, read your article, use your theories or your findings in that particular domain. So that also is counted and some weightage is given. That is the altimetrics. So we'll see few of them. Like most journal level metrics are calculated from the pool of journal indexes into two citation indexing database. Very commonly used are Web of Science (WOS), which is basically Clarivate analytics. Clarivate use all these particular analytics. If you have your Web of Science or Publon login, then you can see your own figures over there. It has lots of like journals, something 11,549 journals from Science Citation Index expanded SCIE, or the social science and art people. It is referred as SSCI, Social Science Citation Index. The library has a subscription of Web of Science does not include access to the journal citation report. So if you have taken the subscription, if your college library has taken a subscription of Web of Science, but it does not give you the access to the journal citation report. That's again a different report, journal citation. And another the platform indexing platform is a Scopus. So Scopus and Web of Science, these are the two very widely used third party platforms, okay, for knowing the quality of the research, right? So the Scopus covers almost 22,000 titles in scientific, technical, medical, and social sciences. Social sciences includes like arts and humanities, okay, and journal metrics are freely available here, and you need to know the more about. You need to have the subscription if you need to know about your own citation or your institute citation. I'll take opportunity here to showcase few of and through examples, through the Scopus. Few examples I'll tell you about the Scopus indexes for few of the reputed universities of the uh, globe, of the world, I mean, and then of the India. Okay, so let me take you there. So this is a Scopus page. I opened it, and if you take the words, this is all visible for you. Just give me confirmation, one or two
Yes,
participants.
sir. Yes, sir. It is visible, sir.
So yeah, so see, this is organizations. I'm typing here the MIT, okay, and MIT. Here it goes. Massachusetts Institute of Technology. This is QS ranked one institute in the world, right? Let's see what the Scopus is telling about the MIT. So MIT, has published so far 3 lakhs, no, I mean more than 3 lakhs documents, something more than 3 lakhs documents so far. If I click that, on this front page, let me show, some few more things to you. So it shows, document whole institution, like 3 lakhs something. Authors you see here, 43,613 so far authors. And here, if you go below, then you'll see like how many articles in the background or in the domain of physics and astronomy, engineering, biochemistry, computer science, material science, chemistry, mathematics, and so on it goes. This is a pie chart of the MIT, okay, and so on analysis you will get. If I want to do the more, if I want more detailed analysis of each of these things, let's say like analysis about the document result, okay. So I clicked all this, analyze such result, then I'll go and I'll find out how many, out of these 3 lakhs, how many publications, sprayed is that there. You see, year-wise publication mentioned here about of the MIT. Okay, so these are the different articles published in the different years. You see the 2019, something 11,000, 20 11,000, up to 22, something 11. It is around 11,000 or 12,000. In 23, it is till date 9,900, 10,000 we can say. And in 24, 84 publications are due in the printed version. Okay, so still we are in 2023, but few publication is going to get print into 2024. It is also mentioned over here. You see the graph. This is a database of the MIT. Okay, this is the database of the MIT USA. You see the graph. Okay, this is the graph of publication. And this graph, I will be telling you about for the different institutions like in India also. I'll after this come back to the some Indian institutes of repute like IITs and all. You see, the research is going on increasing from year by year. The number of the publications in the year, if I scroll here in 190110, I'm talking about MIT, US ranked number one institute. In 1915, it is 16 document. In 1929, it is 84 document. 1957, it is 406 document. I'm talking about MIT. And then it has gone up, 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 up. Now in this era, I mean, this is gone up like exponentially. And now it has reached up to the 11,000, 12,000, or 10,000. This is the graph of MIT. This is the graph obtained from the database of the MIT. You can click here and find out the interesting there where they publish. They publish in very good peer reviewed journals, physical reviewers, very highly rated Journal of American Chemical Society. There they have published almost 4,500 documents. Nature is very toughest to get. Okay, very tough to get through. Nature journal, it's very highly impactful journal. You look at the highest rated journal, then the Nature comes on the top, and the Nature is in top 5 in MIT. Okay, so there's a top 5 journal and Nature is at the 5th position. Okay, so this is why you'll find out like why MIT is at number one. Okay, so if you look at the source, it will give you so much of, this information. We go on to the author. They know how many authors publish the papers. That author-wise publication data you will give. Affiliation, how many affiliations other than MIT professor also may have collaborated with other institutes. All those data also will be presented. So this is all database, Scopus database of the MIT. You see, the MIT itself has produced so many 3 lakhs papers. Then, along with the Harvard, they have produced something. Broad, Harvard University, and so many other. Okay, so this information also gets gathered from the Scopus database. How many countries involved in the publication of MIT? So, United States, United Kingdom, Germany, China, France, Canada. How many contributed? How many countries contributed to MIT's this research database? Okay, that also being recorded over here. Then very interesting, when we go across in NBA and conference, NBA and NAC, the expert always ask you, how many journal and how many conferences you publish. So this is very interesting and very important data. So Scopus gives you idea about that also. This is MIT's data. Out of 3 lakhs publication, 2 lakhs 15,000 publications are the journal publications of the MIT. Conference publication has something 62,000 something. If you take into the percentage wise, then 70% publication of the MIT are into the journal. Okay, then you have conference publication 20%, review articles 3.6, book chapters 2%, letters 1.1%, editorial zero point 0.8, and so many others. So this is the analysis of the MIT, and then how many sponsored projects, funded projects contributed to the publication. That also you get from here. NSF is similar to our DST in India, National Science Foundation. So how many projects supported from the National Foundation, Science Foundation, NSF, are recorded here? Whenever you're publishing, if the support is given to you from financial support, I mean to say, then you need to put it into the acknowledgement section. That also get gathered into your database. That is very, very important. You have to mention all these things when you are publishing your any article. It may be a journal article or the conference paper. So you mention that, then it comes into the database. Okay, automatically it gets into the database unrecorded. So this is the typical Scopus database. Okay, just one more institute will take across the world. It's a very famous. Let's take Cambridge or Cambridge. Okay, let's take Cambridge. So Cambridge maybe second or third into the QS ranking, QS world ranking, and see the figure of the Cambridge, almost also at par with MIT, 3 lakhs 30,000 approximately the articles of the University of Cambridge. Okay, how many authors? 32,678 authors contributed for that. You see the documents by subject area, affiliation hierarchy also it will give here, you know, and then the collaborating affiliations, Department of Physics, how many contributed, University of Oxford, Faculty of Mathematics, all those information also will be gathered here. The documents by source, nature comes first here. It's very interesting. Let's go to the synthesis or analysis of this particular database of the Cambridge University, University of the Cambridge. Are you with me? Are you getting this? Or I'm going fast? One or two feedback maybe. Is my pace okay? Hello?
Yes, sir.
Yes, sir. Yes, sir.
Yeah, fine. Okay, so this is Cambridge data, a database of the Cambridge from the Scopus platform. You see the publication count, almost 13,000, 14,000 per year in 2023, almost to the 12,000. And in 24, 140 publications are going to be printed. Okay, and then source data, nature is very tough to get, as I mentioned, right? And it is on top one first journal or the most publication of the Cambridge coming into the nature. Okay, so that's why these universities are top ranked university. Getting published in Nature is a lifetime achievement. One publication in Nature, and the University of Cambridge has almost 6,000 publications. It's top top journal as far as the publication in for the Cambridge, right? And that counts a lot, and that weightage is too much. Physical Revelator. This is a number one journal for the MIT. It is at number four in the database of the Cambridge. Then we have then at number two, monthly notices of the Royal Astronomical Society. You have Astrophysical Journal at number three, okay, and so many other journals lying up here. So this is a database of the Cambridge. I'll show one or two more interesting facts. You see the journal percentage in the whole publication count. Journal is almost 73.7 and conference publication is 8.3. Okay, this is the stamp of the quality. Journal articles contribution 73 with the top rated or mostly where the papers are published in Nature. Okay, so this is how the hallmark of quality. Now the spread of the contribution of the countries, United Kingdom, then United States, Germany, France, Italy, Australia. So collaborating institutes are also quite good here, right? And then you have subject area. You see the most publication coming into the domain from the domain of physics and astronomy, medicines, biochemistry, engineering, social sciences, material sciences, chemistry, and so on. Okay, so this way you get plenty of data from the scopus to know about, I mean, from how your research is going, how your institute's research is going. I'll show something about like from the India, like let us take IIT Bombay. So this is IIT Bombay's page. IT published so far 49,000 articles, the papers, and if you go into the analysis, then it will show the some interesting facts here. And this is again interesting. You see in India, you have seen this curve, yearly publication count. Okay, uh, and in MIT it starts from 1975, and good publication starts. Here in if you see the IIT Bombay, the publication really shoots up from the year 1996 or 2000, we can say, and it goes up, and then now it is almost publishing 3,000 or 3,500 publication per year. Okay, you see the year-wise publication data mentioned here. It shows the on graphical on the right hand side. By source, very interesting. We seen for the MIT and the Cambridge. For the IIT Bombay, the most of the publication are in lecture notes in computer sciences. 562 papers there. And proceedings of SPI, those who work in optics, they can understand this. So SPI is so optical society basically. 343 articles there. AIP conference proceeding 309. Industrial engineering and chemistry research 253. In inorganic chemistry 248. Journal of applied physics is 228 and so on. Okay, and then type of publication, percentage figure will take. So article percentage, journal percentage figure is 67.3, conference is 25.4, book chapter 2.9, review 2.4, editorial is zero point 0.8 and so on. So this is a database of research database of IIT. We can see like the funding from where the IIT has got funding for the research, and they acknowledge in their articles. So that database shows that most of the projects are from the Department of Science and Technology. Then their own funding, IIT Bombay, Science and Engineering Research Board, SERB, CSIR, NSF, okay, and so on others. So this is the database figures for the IIT Bombay. Okay, so it's quite interesting. So this is how your database is created when you publish article, and if it is the Scopus or Web of Science Index, all these particular get captured automatically by the Scopus or Web of Science, and you can see your institute's database through the Scopus or Web of Science. Okay, on this platform very easily. I hope you understand this database. One or two confirmation, please. Or if I want to focus on something, or I have to illustrate something, you just let me know. Is this okay?
Yes, sir.
Yes, sir.
Yeah. Okay,
Yes,
fine.
sir.
So, okay, where I was. Here. So this is about the two platforms indexing databases like Web of Science, which comes from the Clarivate Analytics. Clarivate is company industry, and Web of Science is its name of the platform. Same is elsewhere. Elsewhere's platform is Scopus. I shown you through the Scopus, the institute's database. Okay, very reputed institute's database. Now it's about the institute. Now I'll come about the journal. So wherever you want to submit the paper, you have to analyze what is the standing of that journal, and based on that you select the where to publish it. Okay, so that your research will be more impactful. There's one screenshot of one of the journal, Marine Pollution Bulletin. It's a journal from the elsewhere. If you go on its website, then you show so many things here. The journal metrics you see here is journal metrics. The side score 3.46. Then impact factor. Often I'm coming with this term. I'll tell you all this, but I want to tell you that this metrics you'll find for the journal when you visit the journal's website. So impact factor is one. Then 5 years impact factor is overall impact factor. Then you can calculate 5 years impact factor. They show this 5 year impact factor and 3 years impact factor and so on. Then nowadays these two figures are also very important: SNIP and then SCI. Okay, SCI MAGO journal rank, SJR rank we call it as, and so these are the journal metrics. Few journal also give you what is the time for the first decision, what is the time for the decision to happen on your article submission, and then how much time it takes up when you get the acceptance mail and the online publication, and how much time it takes from the acceptance to the printed uh, but to the print, I mean actual print. So how much time these also like gives you some of the journal gives you all this information also. So you have to see this particular figure, you have to understand all these metrics. What is side score means? What is impact factor means? What is a SNIP means? SGR means what? Okay. So these are related to the journal, and strictly to the, very particular about the journal. And then based on that, you have to take the decision. On the here on this side, on the top right hand side, there is one interesting thing which is Ultimatrix. I told you, like, Ultimatrix is the thing which is popularly coming up now, and this Ultimatrix may overtake to this general metrics what shown on the extreme bottom left hand side. Okay, so Ultimatrix talks about, your article, how it is, like, how much amount of activity taken place in social platform, and about people are talking about your article, what is the opinion they have mentioned about your article, Twitter, then Facebook, science blog, mainstream news, and all so many other people, social platform or practitioners, what they're telling you about your article. So all that information also is gathered, and then matrix is created, that is called as a ultimatrix. Okay, so this general impact fact. Now I'll talk about one by one all these metrics. So very first is general impact factor. It's very popular. And when I was pursuing my PhD during, like, the time of, like, 2010 and so on. So that time this general impact factor was very popularly used term to find out the quality of the journal. Okay, all other, like, metrics like SNIP or HJR was not so very popular that time, but journal impact factor was very very influencing and very very considered to see, like, the quality of the journal. Okay, and based on that journal impact factor, your journals are categorized typically by the scopus into the four segments called as Q1, Q2, Q3, Q4. So quartile 1, quartile 2, quartile 3, and quartile 4. So the quartile 1 means it is a highly rated journal, top 25% in Scopus database, whatever the journals are there. The top 25 finds the place in the Q1, and then the up to 50 it is a Q2, and then up to 75 Q3, and then all the last remaining is into quartile 4. If you look at the NIRF handbook, the Government of India issues, they assess your database, your institute's database, there is one ranking, I mean, for the quality publication. So how they see quality publication your institute has produced. So this is, they face the data of your institute from the scopus and find out how many publication are in top 25, I mean, in quartile 1 journal. Okay, so that is highly rated. I mean, out of 35 marks assigned to the quality publication, 20 is assigned to how many publication of your institute is landing up in the quartile 1, and 15 marks is for the quartile 2, 3, and 4. Okay, so this is how is important to publish your paper in quartile 1. So this journal impact factor is very very important, and that decides where the journal is going to be. If you put your journal name into the scopus, I'll show you. We go to search source, and if I go with, let us say, nature, which is very famous. Okay, so nature in astronomy, then you'll find all the site score 18.1. This highest percentile is 93%, means obviously it is a quartile 1 journal. Okay, so you see, like, here in the first quartile, second quartile, third, and fourth, for this uh, search result I opened all. If I want to know only quartile 1, find sources, I have to give the name here. Yeah, and nature astronomy by default is there. So nature astronomy is in quartile 1. Okay, so quartile 1 search was given. So this is how you can find out for your domain. You can find out the publisher and all, and then tick on the quartile, and you'll get the list of the journal which is in quartile 1. So this is how from the Scopus platform you can find out. Otherwise, you can visit to the journal website, and then you can read the information available on the journal website. But sometimes, some it happens when we don't have a knowledge about the journal, and then something new journal comes in front of us, and how you verify. So that time you can go to the Web of Science or Scopus, put the journal name and find out and verify all this. Otherwise, there are plenty of paid journal nowadays into the market, and all those paid journal, they give all fake information on their website that is Scopus. The published paper are into the Scopus indexing or Web of Science and its quartile one and so on, but really they are not. So better is, you go and see the website of the Scopus or Web of Science and put all those information and verify. That is the best way to do. Okay, to come back to my presentation. So this is about the journal impact factor, and then one more very important number is the eigen factor. Okay, so eigen factor is again based on your the citation received for the journal. Okay, so it uses the information from entire citation network, okay, to measure the importance of each journal, such as Google's page rank algorithm measures the importance of websites on the world wide web and so on. So all those citation from all the platform it takes, and then find out the eigen factor of the article. And also it gives the article's influence, eigen factor score for the journal, and eigen factor and AI, I mean article influence, this called AI in the journal for the journal in the journal indexing, AI number of the journal. So these two are found on this particular website, eigenfactor.org. If I type here also the nature, let's say nature, uh, find journal, and it will show you the very interesting figures. This eigenfactor for the nature is 1.443, AI is 22.2, and so on. So these are the numbers obtained for the journal from basically with the name nature. So you have nature, pure nature, nature communication, nature genetics, nature materials, methods, nanotechnology, medicines, biotechnology. All these are from the nature. So there's plenty of information you'll get once you type all the name of the journal about from the eigenfactor and the article index. Then the site score. This is obtained from the elsewhere. I will skip this because I have mentioned. I mean, I talked about the site score from the Scopus page itself. Then the SNIP and SGR indicator. SNIP, in one of the screenshot I shown here, like these are also the metrics for the journal, and then SNIP is source normalized impact per paper, which is a ratio of raw impact per publication divided by relative database citation potential. It corrects for subject specific characteristic of field someone is publishing, is so any other two journal can be compared. So SNIP is basically, and if you have want to know the relative comparison between the two journal, you have to compare. You have to compare with this SNIP. Otherwise, it is seen like, why SNIP comes into picture is when the previously impact factor, general impact factor only was the sole tool, but later on it is seen that in few domain, the publication happens very rapidly. For example, in chemical engineering or in civil, publication normally seen happening or coming very rapidly compared to the publication from the domain of physics or mechanical engineering, electrical engineering, and so on. Okay, publication are very slow. I mean, not so many publication coming out. So that's why journal impact factor, which is basically counted based on citation. If the domain is not producing too many of the publication, then naturally the impact factor is lower side. But that's not a correct replica of the quality. So that's why the new indices has come, and new index has come, and these are nothing but SNIP and SGR. SNIP is used, based on the citation received from the similar domain. It do not consider the citation from other domain. Okay, so this way the ratio or normalized figure obtained for calculation of the impact factor, so-called SNIP, is giving the fair idea. Okay, and then it is not domain bias. So that's why this SNIP is considered nowadays very strongly ahead of the journal impact factor. So is the SJR indicator. Okay, so a citation are weighted. You again here SJR, what is considered is citation is received, but not only numbered from which journal the citation is received. Let's say if you publish article and then you get a citation from a Nature, which is very highly valued journal, then naturally your SGR indicator for your article will be very high, or your the journal will be very high. Okay, journal receiving citation from very highly rated other journal. So this way, the SGR indicator gives you the more the conclusive idea about the quality of the journal. Okay, so these are found by the found on various platforms like the this is the I'll show this for HCR calculation. This scimagojr.com is normally referred to get this particular indices. Okay, let's visit that. It's taking time. Yeah, let's go. So this website in here also now, if let's try for the Nature and click it. Uh, yeah, you see the information coming here for the Nature. It's a Nature publishing group from United Kingdom. The country is United Kingdom, and if you click on this Nature, then you will get all those metrics. So subject area and category is multidisciplinary. Okay, publisher is Nature Publishing Group. H index is 1331. I'll talk about it, H index later. Okay, and so many information year wise, like multidisciplinary, how rigorous it is, and then how many similar journals we have, like Science, Sale Discovery, and then SGR is talking about quality index, how it is with respect to the year is mentioned on this graph. Total documents, in the year wise, total documents mentioned here. Total sites and self sites. So, it is always better journal if the self sites are less and other sites citation are more. Okay. So as I mentioned, HGR counts like more, it's give more weightage to the citation received from the other journal. Okay, and that too from not from the same author, right? Self citation. So reduce less self citation, more the quality of the journal. Okay, so this is all information that you get from this particular website about the journal. So this is journal metrics, and then article level metrics. So far I talked about journal metrics. Now when it comes to the article level metrics, means the article which you publish, the journal which you publish, how to measure the quality of that particular journal. So that is given by this article level metrics. So how it is referred, how it is the how that quality is measured. So it is measured by like how many times that article is cited, how is the tracking in social media, how the people are talking about that journal after reading, like on LinkedIn or on Twitter or other. But be sure that you are not like sharing that article, complete article, just for getting this. I mean, comments on the social media. You can't share your article PDF file as one to one directly onto, because it's not the it's your right. You have given a copyright, okay, to the publisher, so you can't share PDF. But it is mean that somebody is reading that by taking some subscription or some other mean, and then commenting your work on the social media. Then what is the geographic distribution of citing the paper? how much citation you received across the world on your article. It's not like you from India published it and you are getting citation from your friends in India. Okay, how is the distribution of citation geographically, distribution of citation? So how many citation you receive from China, then Europe countries, the America, and so many. Okay, so that is also being considered in the metrics. What is the disciplinary distribution of citing paper? So let's say if I'm from mechanical engineering, but how many citation I'm receiving from other disciplines on my article, from electrical engineering or computer science, from medical science, material science, etc., etc. What is the impact outside the scholarly community? So from your domain, not only from domain but outside your domain, how is its impact? That is seen, right? So these are some of the parameters by which the article level metrics are uh, found. You see, this is one of the a screenshot, and this is the article. Okay, this article mentioned over here, and for this article, so many citation data is mentioned here. 31 times it is cited. It cited references, and then all time cited citation count 32 in all database, 31 in Web of Science core collection. There's Clarivate has given a citation 31 times, and then 29 in BIOSIS citation index, one in Chinese citation database, okay, and so on, like other database data citation index, zero in Russian science citation index. So these are different index. Normally in India we refer to the Web of Science and Scopus. Okay, the Scopus is very standard worldwide. It is mentioned. So 31 times it is cited into the Web of Science. So these all information it gives, for your article. If you somebody has published, then you can go on to the website and find out all these metrics. So this is called article level metrics. Okay. Now, very free tool is Google Scholar, and this is many of you would have may have your own Google Scholar page, and so many the index, etc., would be there. So this is useful for authors and publication in discipline less well covered by the commercial services. Okay, and this is a product of Google Scholar. But the problem uh, with this is, if any non peer reviewed article is also if published, then the Google Scholar do not discourage all that. It consider in its database, and you will find its place in Google Scholar. Whereas that's why Google Scholar is not very formally or taken as a standard of measurement of quality, right? Rather than NIRF, I mean, and that's why in NIRF, the two platforms considered are the Scopus and the Web of Science. Okay, Google Scholar, as I mentioned, it covers anything which is not peer reviewed. Anything found in a Google, it is considered as the Google Scholar article. Okay, so that's the problem, and that's why it leads to the other better platforms such as Web of Science and Scopus. Okay, so this is one of the Google Scholar page of one of the professor from Florida University, and you see here on Google Scholar, it gives so many information about citations received overall, all citations, and then on the right hand side, it gives the citation since 2012, and then H index, I-10 index. These are the two parameters, now people talk about and refer, and then compared with each other with this H index and I-10. This is the sorry. Yeah. This is the link through which you really can find out you can type the author and find out its page if it is mentioned that open to anyone. Let's go and try out those who haven't seen tried. This may be a demonstration for them. So let's say like Placid Pereira is alumni of SPCE. Very proud to share his Google page. Uh, SPC alumni, 19 maybe 75 batch. He's professor at University of Illinois at Urbana-Champaign. And you see his Google Scholar page. His citation is 15,631 on his articles. H index is 63, I-10 index is 153. Okay. And one more we can refer to NC. NC Siva Prakash, uh, our mentor for SPC. Uh, so look at his particular Google Scholar page. So citation is on his article 611, H index 13, I-10 15. So what is H index and I-10 index? So let me take this opportunity to tell you at this particular moment to tell about the H index and I-10 index. So I-10 index is nothing but how many article of yours cited more than 10 times. Okay. So I'll take this page to uh, show you this particular how I-10 is calculated. So this is more than 10. So first article 1, then 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11, 12, 13, 14, and then 15th article is having uh, s- uh, citation more than or equal to 10. So I-10 index of Professor NCC Prakash is 15. Okay. Are you with me? Are you with me? Just to
Yes, sir.
confirm.
Yes, sir.
So
Yes.
I-10 means how many of your articles cited at least 10 or more than 10. Okay, 10 or more than 10. Okay, so on this page you'll find 15 articles found which are cited at least 10 or more than 10. Okay, so the I-10 index is 50. That's why I-10 index is 50. You see, this article is 9 times outed. If somebody cite this and this becomes 10, then I-10 index becomes 60. Okay. Now, what is H index? H index is when we arrange this in descending order, and by default, Google Scholar will arrange your article in descending order. Okay, so already this is in descending order of citation. So top rated citation who received most rated article is which is cited most. So this is 1, 2, 3, 4 like that. I mean this is in ascending order. You find out the serial number. Okay, the citation more than the serial number, that is called as the H index. Okay, so when you go to 13th article, the 14th article may not be having the citation as the 14. Okay, so that's why the H index is a 13. Okay, I have one more illustration to show you there. It can be I mean more clearly discussed. Let me go to my presentation. Okay, so we go to that illustration here. Here you see. So this is the serial number. Okay, and this is the serial number of the paper, and this is the number of citation. So your number of citation received on the first article is 75, second article 68, third article 65. So now this is the article number 7, which has got 12 citation, and the next article, 8th article, has got 9 citation. I-10 index so is the 7, because number of papers which are having citation at least 10, okay, is 7. So I-10 index is 7. Now when these are arranged in descending order, you will find the citation of the 9th article is 5, which is less than serial number, but citation of 8th article is more than serial number. So that is the H index of yours. Are you with me? Are you with me?
Yes, sir.
Okay. So
Yes, sir.
serial number 8 has got more citation than the serial number. Okay. So that's why H index is 8. At 9, 9 number article. So provided this has to be arranged in descending order. The ninth article has got number of citation 5. So this is 9 cannot be H index, but H is the 8 is the limit now, where this is a cross boundary is happening. Boundary is taking place. So your H index is 8. Okay, this is how your H index and I10 are calculated. Okay. So this is all about that. And now the one more is calculation of this journal impact factor. Okay, how the journal impact factor is calculated. Now you see this is now journal impact factor calculated based on 5 years average or 3 years or overall. Okay, so this time can be different. Okay, uh, so this is one illustration for the calculation for the 2 years specifically. See the number of papers, number of citation received in 2007 is 263. In 2006 it is 373. Sum is 637, and number of articles published. Okay, in 2007 is 55. 2006 is 49. So number of article published is 104. Now when you are dividing, okay, I mean on numerator, total citation divided by total number of items published, okay, that gives you the journal impact. So it's a citation per article, citation per article in some definite time, that is called as a journal impact factor. Okay, now here we haven't considered how many citations are received from the same journal or from the same author is receiving citation from his articles, previously published article. If that is not considered, okay, that is excluded, okay, then you get a revised impact factor, and that is more quality, that is considered as a more quality factor. Okay, understood. So when the journal citation came from other journal is taken more, okay, or more impact, or otherwise the citation coming from the same journal are excluded, then that is the another journal impact factor, excluding the self citation, and that is valued more compared to the generalized normal journal impact factor. Okay, so this is how your the index are calculated. One more is HJR. As mentioned to you, HJR is more qualitative, as the impact factor has some pros and cons. So HJR is uh, more considered quality factor. And HJR, this equation is a very complex equation. Basically, theme is that you in HJR you consider the citations coming from which journal, how much weight of that journal is. Like I mentioned to you, if the journal the citation coming from very top rated journal like Nature and so on, Science, Nature and so on, which are very having high impact factor, then naturally your HGR will be more. Okay, so that way this formulation is done and it calculates the SGR. Okay. Altmetrics is one more index, and altmetrics takes the like the your comments from the different practitioners, researchers from the different domains, their comments, and that comments are quantitative, sometimes qualitatively, quantitatively, and then it is figured out for getting your altmetrics number. This is the website of the altmetrics where you can find the metrics for your article. Let me share this. Yeah. So this is Ultimatrix a website, and from here you can get all those information about the impact, its citation, from where it is coming, etc., etc. Okay. There's a link is there. You can explore more. Uh, so what Altimetrics address, as I mentioned, it takes information from all the different parts, such as from different domain, how many are reading, its geographical, the spread of the sharing of your article or discussion on your article, etc., etc. Okay, so this is one graph, I mean picture of the one of the Springer article uh, in the Altmetrics. If you go onto that Altmetrics website and type your article or the publisher, then it will give you all those information, demographic breakdown on it, how many percentage of that particular article or the journal is referred by which of the countries. Okay, then the which of the countries, then what are the societies, okay, how they used it, etc. All this information you will get from the Altmetrics. Self-metrics is nowadays coming very popular and gives more of the information. This is again the Nature Climate Change, a very popular journal, and you will get the Altmetrics score over here, tweeted by 14. So 14 people on Twitter has tweeted about that. One on Facebook page, picked up by 11 news outlets. So very impactful journal. Sometimes you article you present and it's make a big headline news in the good newspaper, and that also is picked by the Altmetrics. Okay, blocked by two. So all this, is the information gathered. Okay, and then it presents this particular figure over here that is called as Altmetric score. Okay, nowadays this is going to be, I mean, in some near future, all other previous figures will go off, and then this will be coming on. So this is how unbiased things it is stated so far. So that's why it's founding a very popular, finding very popularity. Okay. This is the link you will find for this particular climate change paper. I mean, taken from this link.
So, should we take a break for families?
I'll complete. Actually, I don't have much of the content now remaining, so I think
Okay, sir. Okay.
we'll
Okay.
complete. Okay.
Okay, sir.
So the end of the journal impact factor may be a very slow process, and now as I mentioned, now journal impact factor, no more people will be using it, and so is the reported in your DORA report in 2012 San Francisco Declaration on Research Assessment. It's a DORA report. You can go through. You click on this. You can click on this link. I'll share this with you all through Professor Rao, and you can read all those documents. Why general impact factor is not so considered now as the qualitative metrics, and it has come up and now they recently come up with a different the indexes as SNIP and HGR and Altmetrics now. Okay, so new metrics relative citation ratio has come, which is SNIP, HGR, and so on. Changing expectation of the funding agencies. Funding agencies are also like bit confused with the journal impact factor. It has given a birth to all other metrics, and Altmetrics, which is more powerful and so-called stated unbiased, as receiving more of the acceptance. Okay, it gives more about the social impact also. And then this is again one captured information for one of the paper, giving again information about the Altmetrics use. You see like 85 is the score, and how it is rated, so picked by one news outlet, blocked by 4, tweeted by 72, 2 on Facebook pages, 2 readers on Mendeley, and on. So this is how the Altmetrics has coming more powerful, and this is how you have to use when you will go and go on publishing your findings. So all these are you have to consider when you are selecting your journal for the publication, for the publishing your research findings. So last is for typically, sorry for the industry person, this particular slide may not be as useful for you, and but it's more relevant for the faculty from academic domain. So research score, other than like the journal metrics and all your article metrics and your own metrics from Google Scholar and all, very popularly, people call like what is the research score of faculty? What is your research score? So the methodology given by the UGC and the accepted by the Gazette of the Government of India. Okay, that I'll be presenting here. So this is the metrics of yours, personal metrics. Okay, so when it comes to metrics, when we call metrics means journal metrics, article metrics, or your own metrics, or your institute's metrics, your department's metrics. Okay, this slide will tell you about your own metrics. Okay, your own score, research score. So your research score is calculated based on journal publication, based on sponsored project, how many you fetched, consultancy, how much you are doing, patent, then conference publication which you are doing, book chapter, students guided at various levels, MTech, BTech, PhD, etc. Okay, so I'll share you the one of the document. How this is calculated. This research score is calculated. So if you get any external sponsor project, but obviously it should be more than 5 lakhs, okay, of rupees, then you get 8 point for that. But 8 point if you are alone in that project. But if you are doing that project with someone else is co-PI and you are PI, then this 8 marks or 8 credit is divided as 5 for the PI, and 3 credit for rest all other co-PI. So if you are having two co-PI, then the 3 marks will be, or 3 credit will be divided equally among the rest two co-PI. Means 1.5, 1.5 like that. I mean, okay, in the case which I am explaining. But sole you are only there, then 8 out of 8 you will be getting there. Then patents granted only if you are publishing patent and it is granted. No marks or no credit for the patent which is filed or patent which is published. Okay, so for one patent also there is eight credit point, and if you are the one investigator alone, then 5 credit point for you. And if there are many other, then if you are principal investigator, then you will get the 5, rest all among rest all the 3 remaining point will be equally distributed. Consultancy is for any consultancy more than 5 lakhs will be counted under the consultancy, or 5 lakhs can be a cumulative sum. It's not necessary that only through a single consultancy it should be more than 5 lakhs. It may be a cumulative one. But for 5 lakhs cumulative, you will get 2 credit point. But there is a ceiling. You cannot earn marks under consultancy of any tune. You can score only up 10 credit points. Okay, whereas the patent, journal, and the sponsored research project, you can score point, any point, infinite, and there is no upper cap for the sponsor project, then patent, and the journal publication. But there is a cap for consultancy. You can earn only up to maximum 10 credit point. Okay, this is guided. If you are guiding a PhD student, then you will be, and you are only the supervisor, then you will get 8 point. And if you are supervisor and some person co-supervisor, then supervisor will get 5 marks and 5 credit point, and 3 point to the remaining all the other supervisor equally distributed. Okay, then journal publication, 4 credit point per paper. If you are the first author or the main supervisor, then you get 2 point, and remaining 2 points are equally distributed among all other authors. Okay, and there is no upper limit, as I mentioned, for the journal publication. But journal publication should be Sci or Scopus or all that. Paid journals are not allowed. Paid journals are not at all considered. These are all norms mentioned in the Gazette of India. Okay. Conference publication, for one conference publication you get 1 point. Okay, and if you are the main author or first author, then you get 0.6 marks, and the remaining 0.4 marks are equally distributed in all other authors. Okay, all other remaining authors. And there is a upper limit for the conference publication, that you can gather the point maximum up to 10. Okay, if your points more than 10, I mean more than 10 you cannot get. It is having cap of 10. So there is a cap for consultancy, cap for conference paper. Okay, then this is all for all other things. I'll talk about research only. So the guidance to the um, uh, MTech and BTech student. So postgraduate student, if one postgraduate student you are guiding, then you will get 0.5 credit point, and there is a cap of maximum 10 credit point. You cannot score maximum more than 10 grade point. But then again, if your promotion happens, then again you can restart and gather all those. You cannot claim after promotion the previous claim point. Like in conference also, 10 is the maximum cap. But if you're promoted, then that goes vanish, and again you have to start and get the maximum again. After that, at that new position, you can get maximum 10. And then undergraduate project, for undergraduate project you can get a 0.25 credit point, and maximum 4 point you can earn from the undergraduate project guidance. And that is valid only to till only to that particular position. And when you are promoted again, you can start and get maximum of the 4 point. So this is how, for guidance, the points are, or your research score is getting accumulated. If you are publishing a book, then there are a 6 credit point for a book, but book should be of a good, it should be published in good publishing house, like McGraw Hill or elsewhere, or Springer or Taylor and Francis, and some like of such repute. And you can have a maximum 18 credit point, okay, in your bag. And there are a few conference paper which goes into the book chapters, and when it goes into the book chapter, you can get 2 credit point, okay, for book chapter, if you are publishing into the good peer reviewed publishers, okay. This is how your score is calculated based on all. I think I covered all: journal publication, sponsor project, consultancy, patent, conference publication, book chapter, and students guiding. So this is how you are quantified. You own as a faculty quantified. Your journal where you want to submit the paper, that is quantified. The article which you publish is quantified. Okay. So these are all metrics giving you the quantification and telling you the what is the quality of the research and what is the impact of your research is happening. These are the attempt made by this metrics. Okay, and these metrics are also used to know your organization, your department as well. Okay, it's not about your article, journal, but also your department, your organization where you are working. Okay. So now, what I'm giving you the task is wherever you are working as a faculty, not where you registered as a research center, but wherever you are working as a faculty. There, I mean, this is assignment for you all. You have to find out the H index and I-10 index of your department and your institute. So this is the assignment. So you have to find out the H index, I-10 index of your department, where you are working, not where you registered for PhD, but where you are working, and for your department and for your college. So this is the assignment to you all. And only one person raised hand, Mr. Mirza, who is from the industry. So for him, the institute will be the where he registered for the PhD. Okay. So here is I take I end, and thank you to the SPIT, in particularly Professor Rao, for giving me this opportunity to discuss with this August gathering here about the database and research metrics. And the contact information is given here: my email ID, my mobile number. I prefer to answer you on my email address rather than on mobile. Not very particular on when you send message on WhatsApp or WhatsApp or other to other mode. But mail, I surely always reply. Okay. So thank you for that, and hope you'll do this assignment. And I'll share this PPT with Professor Rao, and he will share with you all. Okay. So thank you. I'll take some questions if you have. If you have any queries, you want any information from me, I'll be very happy to answer those. Thank you.
Thank you, sir, for the nice session. We have some questions in the chat box. One
Oh
question.
yeah, sure.
One
Sorry.
question is, what is the use of H index if I-10 index is giving the same information?
No. I-10 and HL both are different. No? I-10 is what is the definition of I-10 is how many publication which are having the citation more than or at least 10. That is I-10, right? And H index is the serial number which is more than your citation. That is the H index. So H index is different and I-10 is different. You can get I-10 very easily gathered, but not H. H is very tough to get. Okay, H is more qualitative compared to I-10. Okay, so I shall see the chat box. Okay, thank you. Anything else here? Uh, design, which type of patent is to be considered? Patent means it's a utility or process or product, not the design. Design registration is different. Anything if you design, if you design your furniture at home, you can have design registration. That is not called patent. Okay, so design is not called at all. Design is called registration. Design registration is different. Have you seen Godrej symbol? You know how the Godrej is written. Okay, that is not patent. That is called registration of logo. Okay, L and T, how they are oriented. That is a different. That is not counted as the patent. Okay, yeah. Our
Hello, sir. Can I interrupt you? I have asked that query actually.
yeah,
I
yeah.
mean, it is not a trademarks like a thing. I'm
Yeah,
asking
yeah.
about the industrial design. That is considered as
Uh,
a patent or not?
that you have to come up as a product or process, then it will be
Okay.
considered. You, while filing, you have to do, and then your assessment will be different. Okay,
Yeah, for the
your
research score,
assess.
I'm asking because you have mentioned no
Yeah,
patent
yeah.
in the
Research.
research score.
No. In research, that trademark or registration is not considered. Only patent granted is considered.
No, no, design patent is a industrial design. I'm asking.
Yeah, but then it should come in the patent category. Then, when your certificate when issued to you, it should be patent. It should not
Okay.
be
Design.
registration of design. Yes.
Okay.
Okay. Process is different in that case. Okay. Yeah.
Yeah. Okay.
Yeah.
Thank you, sir.
Parth has raised a hand. I'd like to hear from the Parth. In NRF also, that design registrations are not considered. They mention if you look at that their hand. Okay. Yeah, Parth. Yeah, Parth has raised hand. Parth, I think he is there or not.
I think he's
Okay.
not there. I think. Uh,
Yeah, so I hand over to the coordinator.
yes, sir. Um, I thank you for giving us insights uh, about the different matrices, journal matrices, L matrix, SNIP, SJR. We will try to solve the assignments, sir. H index and I index of our department where we are working, and it was really a nice session and informative session. Sir, I have one question. The question is like why L matrix is more important than journal matrix?
Altmetrics has come recently, ma'am, and as mentioned, the uh, the falsification in the which is found as a and it was noted as a concern in Dora report, which I mentioned, and one of the links mentioned in my presentation. You can refer to those the minutes, and concerns raised with the journal metrics, journal impact factor or other metrics. Okay, because of that, alt matrix has come because alt matrix is more said to be cannot be in false, or cannot be manageable so easily. So that's why Ultimatrix is considered and coming up very powerful nowadays. Okay, that's the reason.
Okay, sir. Thank you, sir.
Because it takes the information, from all domain, open to all, not only for research community, to practitioners, to general people. They discuss, they can put their thoughts. Okay, it's not based on complete citation. It considers, it's publication in good reputed newspaper also. Okay, like in the Times of India or Herald or something. Okay, community based, the utility based voice. If something happening, like big thing is happening in technology, and it gives the impact to all the ground level people also, they will also talk about something, how this innovation is good. So that voice also is captured, whereas in journal impact factor, only the citations were considered, which is from the same domain or some other domain of the engineering or sciences, not the common public. So that's why this ultimatrix has been regarded very high, but
Okay.
not very popular now. It's still coming up. Okay.
Okay, sir. Thank you, sir. I'm very thankful to you for giving time and guidance about the databases and research matrices. And I will stop here. Thank you, sir.
Yeah, thank you very much. Thank you for giving me this opportunity. And I will share my PPT with Professor Rao. And
Yes, sir.
you do complete the assignment which I have given to you. You have to uh, find out H index. Again, I'm telling. Otherwise, in the mail, I'll write to Professor Rao.
Yes, sir.
You have to
That was.
find out the H index and I-10 index of your department where you are working, and also of your institute where you are working, not where you registered for PhD. Okay, okay, because there may be a few centers only. So wherever you are working, that department's H index, I-10 index you have to find out, and your institute's H index and I-10 index you have to find out. Okay, okay, and for the industry person, the department and the institute will be where is the research center. Okay, I think this is
Yes, sir.
clear, right? Yeah. Okay. So this exercise will make you to understand very clearly how H index and I-10 index is at least calculated. Okay. You do this exercise and complete this.
Yes, sir. We'll submit it as a assignment. Thank you, sir.
Yeah. So thank you very much. So shall I leave now?
Yes, sir. Rao, sir, I think he's busy in some other work. So,
No, I'm listening. Yeah. Okay.
Okay. So this assignment I have given them, sir,
Okay,
so
sir.
that they'll exercise, they will understand how these index are calculated.
Okay. Okay.
So for widespread, I have given that they have to consider their department for a case study and their institute, because
Okay.
research center will be very few. So for
Yes. Yes.
variety, this can be good. And for industry person, it will be the research center where he registered
Okay.
or
Okay.
taken admission.
Yes. 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 Good.
Okay, and I'll be sharing this PPT with you, sir,
Okay.
soon
Okay.
now.
I will inform them. Yes.
Yeah, yeah. Thank you, sir. Thank you.
Thank you, sir. Thank you very much.
Bye.
Okay. I think today this is the only session we have,
yes, sir.
and yeah, I will mail you the link of the quiz. You can finish it before 9 p.m.
Yes, sir. Yesterday's question will be there, sir. I mean,
Yeah, they will be there again. Yeah.
okay, sir. Thank you, sir.
Hello, sir.
Yes, sir.
Sir, are you sending the pin again on WhatsApp group?
No. This time it's not a group. Not at one time.
Okay.
You can log it at with your own time and do that,
Yeah, yes.
because all of them are not available at the same time.
Yes, yes.
So some of them are traveling. So I will send you a mail. So you can do it as and when you are comfortable, but
Yes.
before the deadline.
Yes, sir. Yes.
Okay, then we'll stop the session.
Yes, sir. Thank you.